Today we are solving a CTF live on camera, and I'm basically going to be walking you guys through my thought process as we go through, as we get context on the system, and then we try to figure out what the bug or vulnerability is. I'm going to basically just be saying everything that I'm thinking as I'm going through, and you can sort of see my thought process and how I approach things. So the CTF we're doing today is Damn Vulnerable DeFi number 10, Free Rider. So actually, if you haven't done it yet, maybe go and attempt it for yourself and see what you find and what your experience is. And then after you've done it, then go ahead and come back and watch this video and see how I approached it. Maybe you solved it a lot faster than I did, or maybe perhaps you didn't see things in a certain way that I did. But regardless, I think it will be very cool if you go ahead and attempt it for yourself and then see exactly how I approach the CTF myself. Okay, great. But of course, why should you care what my approach is to the CTF, or what I'm thinking as I go through a CTF? Well, first of all, my name is Owen, and over a year and a half ago, I founded Guardian Audits, and ever since then, our team has uncovered dozens and dozens of high and critical vulnerabilities and performed smart contract audits of over several hundred smart contracts and spent over 1,000 hours doing it personally. So my goal with all of these videos, and especially this one where I show you my thought process around a CTF, is to take down all of my experiences over the past year and a half and give them to you so that you can ultimately become a much better smart contract auditor. All right, guys, without further ado, let's get into the live CTF. All right, so today we're on Damn Vulnerable DeFi, and we're looking at this challenge number 10, Free Rider. And this is a part of the Damn Vulnerable DeFi V2 that was recently released. I haven't had a chance to look at any of these new challenges, but today we're going to do just that, and we're going to dive in live and try to see how much I can embarrass myself by trying to do a CTF live recorded and sort of poke around, discuss all of the things that I'm thinking about as I go through the CTF, and yeah, just sort of figure it out as we go. And if you have solved this free rider challenge, then you can first of all go and make fun of me in the comment section below as I'm going through and potentially getting stuck on things. But then, of course, if you haven't done this free rider challenge, then I think it'll be really fun to go through it together, and you can see what I'm thinking as I sort of go through and what stands out to me, and how I code up the POC and the solution to it, etc. So without further ado, let us dive into this challenge number 10. So we'll start off by just reading this challenge. So a new marketplace of damn valuable NFTs has been released. There's been an initial mint of 6 NFTs, which are available for sale in the marketplace, each one at 15 ETH. The developers behind it have been notified the marketplace is vulnerable. All tokens can be taken, yet they have absolutely no idea how to do it, so they're offering a bounty of 45 ETH for whoever is willing to take the NFTs out and send them their way. You've agreed to help, although you only have 0.1 ETH in balance. The devs just won't reply to your messages asking for more. If only you could get free ETH, at least for an instant. Oh, well, that is a little on the nose. I think there has to be a flash loan involved here. There just has to be, based on that last line. So there's a marketplace that has a bunch of NFTs, and essentially there is a way to take all the NFTs. Okay, so let's start off. We can go ahead and clone Damn Vulnerable DeFi here, and we'll go into it, damn, and then let's see. Let's open up IntelliJ. Okay, here we are. We've got Damn Vulnerable DeFi opened, and let's see. We'll go to the freerider challenge.js. So the first thing I like to do is actually read the scenario and the whole test scenario, the before and after, to first get an idea of what the scenario is. And sometimes you can glean a good amount of alpha just in the exact after conditions. You can see what kind of happened. My goal will be to get an initial high level understanding of the contracts involved, and then we will go ahead and see if we can uncover anything from there. So first of all, I can see, of course, we've got Uniswap involved. So I'm thinking that that is obviously going to be related to a flash loan. Almost certainly. Let's see, we've got NFT marketplace. We'll have six tokens for whole marketplace. Okay, and the marketplace is going to have Ether. It's interesting. Okay, there's the 45 Ether balance. Cool, so I see player has some Ether. We're deploying stuff, deploying Uniswap, setting approvals, add liquidity. Oh, okay, so we're basically just deploying the pair when we do this. I did not know that add liquidity ETH automatically created the pair. That's pretty cool. Okay, so then we're actually getting the pair. I think it's, yeah, it's pretty obvious that there's going to be a flash loan here. If in the setup we're going through all of this to get the Uniswap pair, and then, I mean, what else would you use the pair for? Let me find, where's it? So if I search here, yeah, so the Uniswap pairs, it's not referenced after it is sort of declared here. So obviously we're going to be using the Uniswap pair in our solution, and that's definitely going to be to get a flash loan. So there's that. So before I even look at the contracts, now I have like a scope to think within. I know I'm going to be looking for some sort of flash loan opportunity, some opportunity that if I had money, I can exploit the system, and then after that exploit, my money will be returned. I'm guessing I'm going to be able to buy an NFT and then get the money back or something like that. Something along those lines. So let's see. Okay, then this is just more deploying, setting the approvals, offer many, open offers. Oh, so there's going to be, I assume, okay, this is for the, right, there's 6 NFTs. And then these would be the IDs. So there's going to be offers for all of the NFTs in the marketplace. Okay, so I bet it's something in the offer logic where, yeah, we'll see. We'll have to pay special attention to the offer logic. I guess I'll write that down as a note. We'll use audit tags even though this is a CTF, but we'll note pay special attention to the offer logic with flash loans. I wonder, I bet if there's a standing offer somehow that the amount for that offer can be returned, and maybe if I can use a flash loan, we'll see. Okay, the devs have a contract. So the marketplace is, where's the marketplace? So the marketplace is this free rider NFT marketplace, and then they have this devs contract. Then they have this recovery contract. Okay, so we'll see what that is. I assume this is like some emergency thing. I guess it will be funny if this emergency thing is part of the exploit. Like if that is what enables. It wouldn't be here in a CTF if it didn't enable the exploit, I'm guessing. Or maybe it's just to get the bounty for the after check. We'll see. So, okay, so the devs extract all NFTs from its associated contracts. So this is where the alpha is going to be. We're going to see exactly what needs to happen. So the devs extract all NFTs, transfer from, this is their recovery. Okay, so the devs are able to recover. So we're sending, if they're transferring from the dev contract address, then we have to be able to send NFTs to the free rider recovery. And then the marketplace, interesting. So the offers get closed. So yeah, like I was saying, I think there'll be something where we can arbitrage the offers or something like that with a flash loan. So let's see. So the balance of the marketplace is going to be less than. We'll see. And then we are supposed to get the bounty, or greater than the bounty. Interesting. Okay, so let's go ahead. Let's dive in here. Start off straight with the marketplace. So the first thing I want to basically understand, high level, what is the marketplace doing, what's accomplished here, so, and how is it accomplished, right? So before I even look at this, I know that we need to be able to, there need to be offers, right? So you should be able to make offers and accept offers. And then also I'm thinking there's probably a way to cancel offers. And my guess actually is that it's gonna be something like, I don't know, I feel like something messing around with offers somehow. So let's see. Okay, so what do we have here? Okay, in the constructor, we are deploying a token, damn valuable NFT, and then we are renouncing ownership. So this is okay, so this is just like a stub. We can safe mint. Okay, so like a stub NFT, we're just minting it to the message sender. Okay, right, so that happens on deployment. So then when we deploy it, I assume we'll see, when do we deploy them? Okay, so the marketplace. Then somebody, so the deployer should have these NFTs, right? NFT roles of marketplace. Marketplace is the minter, deployer, right? The deployer owns, and then it sets the approval for all so that the marketplace can use them. Okay. And those are the 6. So amount should be 6, right? Amount, right, and this is 6. So we're basically deploying all of those and then setting the token. So interestingly, here's offer. Oh, and they have a buy. Yeah, it makes sense. Okay, so you can offer many and buy many. Okay, so let's see what's going on. Bunch of validation, not too interested in that. And then offer 1 is going to the token. Okay, then yeah, validation, offers. Okay, so we set the price. Ooh, something I'll note is that this gets overwritten. Let's see. Let me have a close look at the validation to make sure we can't have a higher offer and then just overwrite it, right? So I'm assuming, okay, it looks like there's actually no, am I reading that right? That they don't care about, so if I look for this, yeah, actually it looks like I can overwrite the price for the token ID. Okay, so this is interesting. This is something, at least it's a lead, so let's see. I can overwrite the offers for a token ID as this price. And I mean, let me check again, but token get approved for token, and token is approved for all. It is approved for all. And I mean the message.sender. Oh, okay. So this is, I see. So the message sender has to be the owner of the token. Message sender. Okay, so you have to be the owner of the token. And so of course it's fine if I overwrite this price. I'm essentially, so when they're saying offer many, it's like putting them up for sale. That's what they mean. Okay, so let's see. I mean, you're calling this with your own thing. You'd want to make sure these arrays are the same length. Let's see, you can set the offers to any price here. And then what are we doing? Oh man, is this going to be some low level bug in this one? Let's see. So we are storing to the second, so what's that, the token offers count. Okay, so what are we doing here to the second? We are, okay, so we're loading, oh, we're just adding 1 here. Okay. I don't think there's anything wrong with that. That ought to be fine. Although it's like, assembly definitely stands out to me looking at a CTF, but that looks fine. So we have offer many and buy many, and that really seems to be, so there is no canceling of offers, unfortunately. And so this is a little bit different than I thought it was actually. So an offer is like, this is like putting up for a sale, and then like they call it what? They call it buying. So you have buying. This is like, buying the NFT. I'm assuming at the acceptable price. If we can get around the price, that would be another story. That might actually, I'm assuming so okay, we know we need to use a flash loan somewhere. Like I'm pretty confident of that. So that's obviously going to be, that's going to be on the buy side for sure. So we have we just loop over the tokens, and it's unchecked. It's unchecked, and I see a minus minus, and actually this is the same memory as this is touching. I don't see any reason why that would. Oh no, is it? I really hope it's not anything like really nuanced. This looks fine to me, but the minus minus and the unchecked. So what is offers count used for? Oh no, it's like I don't know what. Even if it did underflow, it wouldn't do anything. I think these are all just red herrings. This unchecked and this like assembly. Oh, this one's unchecked as well. Okay, so let's we'll note that maybe we'll come back to this idea. I mean, there's really not much to come back to. Like this literally doesn't matter unless actually if we go to the other contract here. Okay, I was going to say if the other contract actually relied on the offers count, then we would have something to work with if we could make it underflow, but I don't see how we can underflow it. It's not used anywhere. So it looks like this is just on ERC 721 received. Okay, of course, this is basically the developers setting up a contract that is like a recovery. Exactly, it's a recovery like contract. And so this is kind of cool. It's like the agreement has been written in code into a contract, and if these stipulations are met, then it looks like, yeah, and then that's when basically the bug bounty is paid out. So that's pretty cool. Okay, so the message sender has to be not the NFT. Okay, I'm going to assume we are the beneficiary. If we go to the free rider recovery, where is this? Free rider recovery. This is the devs. Yeah, this thing. Okay, we are the beneficiary, right? This makes sense, yeah. So it's like sort of like the agreement between us and the developers. Yeah, we have all this validation. Okay, so it's only for these tokens. Do they validate that it is actually the collection that they're looking for? Invalid token ID, still not owning token. Token ID, okay. You have to have transferred it. All right, so I don't think we're going to be able to trick this by manipulating, but it's worth noting that there's money in there. And okay, so we need to think about flash loans. And so let's think, okay, so when we buy one, there's a price to pay. That's just it's the current offer that's standing. And then we check if there's less than, oh, but okay, so we use the message.value, but the thing is we are calling this function a loop, right? So we are buying many. So if you call this function with a value, so the message.value, I don't see this necessarily changing. It's just requiring that this it has to be greater than or equal to the price to pay. I think that I didn't expect it to be something so obvious. This must be like, are they adjusting? I mean, the way it looks like, so I mean, if we walk through, so here's my idea, right? And I've actually seen this in a few instances before where I remember there's some like Open Zeppelin report where the only reason I know of of this particular instance, I think I saw like a video of like projects that were hacked after the audit report, but they actually made changes. So there was some like Open Zeppelin report on some protocol. They audited it. It was good. It was safe at that commit. and then they had presumably they made significant changes to the protocol and deployed afterwards, and they're actually hacked for this reason because they were using message.value in a for loop to do basically what this looks like it's doing. Yeah, and basically like unintentionally multiplying the message.value by the length of the loop, right? So that's what I think is going on here. I also remember actually looking into this because there's an issue when you have like a payable multi-call, is that in a payable multi-call, you well, it's a multi-call, right? But in every single sub-call, you have the same message.value. So it's an issue there as well. So that's why this automatically is standing out to me. So if we just walk through, my idea is that basically the message.value is going to be essentially multiplied by however many iterations of this loop there are. And so let's walk through it. Let's walk through it. Like the message.value is never going to be reset. So let's say I'm going to buy many. I'm going to buy all 6 of these tokens. So let's see. We are going to buy one. We get the price to pay. Whatever the price to pay, the message.value. So as long as we get over the most expensive token, right? So let's say the first token is the most expensive token, or I mean, they're all the same price actually. I'm pretty sure, right? So yeah, so they're all, when we offer many NFT price, NFT price, NFT price, NFT, they're all this amount, which is 15 ether. So if I just send 15 ether to the buy many function, then what happens is we go into buy one, and so the message.value is 15 ether. Price to pay for all of these is 15 ether, but see that the thing is they might be smart about it in that they're sending value. So I mean, if we go to, it might actually be fine, annoyingly, unless, I mean, you could still game it by, I got a yarn install here, or just yarn. Okay, so it might be actually still fine, but you could, this might be where the flash loan comes in, is that you need money to exist in this marketplace because we have to be able to send price to pay. We need money to exist here to be able to do that. And then, but we do know that it's going immediately to the owner of. So if we can somehow have, oh, but is the owner of, is that token.owner of? But did this not just change? So the token safe transfer from owner. Oh, wait. So hold on. So we transfer, so the token transferred from the owner of the token ID to the message sender. So the message sender gets it. And then now we do, so this presumably is the message sender after we do this safe transfer from. So it's actually flawed, it looks like. So the price to pay, right? Wouldn't you, this is going to be updated, like the owner of. So this is the original owner here, but then when we transfer it from the original owner to the buyer, now the owner of is this buyer. So then we're going to end up sending that money to the buyer. So it seems like several things are wrong here. But yeah, so if we're sending money to the buyer, actually, that is interesting. Seems like I could buy one at a time and still exploit it. Oh, it seems like there's maybe several ways to do this, but let's see. So if we buy one, if we do this, if we do the version where I'm buying all of the tokens at once, message.value is less than the price to pay here, then what has to happen is there's a transfer out. So the issue with the transfer out is that if I'm going to make, so let's say this is 15, my message value is 15. So I transfer 15 into the marketplace, and then I send 15 out to what really should be the owner, but it's actually, the new owner, which is us. But the issue is that when we come back into the second loop, we come back here, message.value is still 15, price to pay is still 15, but now when we try to send this value, it will fail because there is no ether in the contract. So I think, is this also even a red herring? So yeah, because it's actually safe unless you, unless you put money into the, if you send ether here so that it can, but then like what's the point of that, right? You might as well just actually pay for the NFTs. So I think our approach can be to, I think it's the fact that the owner here is actually, this is the new owner, which is us. So what we can do is we can buy one and just keep buying one, like buy many. Yeah, it's interesting that it's structured in this way where there's only many. So there's an offer many and then a buy many. There's no like exposed buy one, but so it's clearly like leading in a direction, but I think it's all a red herring. Okay, so we're going to buy many of one token at a time, and then we're going to get, this money is going to come back to us in the form of ether. And then so once you have 15 tokens, you can just buy everything. So that's what we're going to do. That's what we're going to try. So let's see. So the issue then is, of course, I remember, so there's this line, you've agreed to help although you only have 0.1 ETH. The devs just won't reply to your message asking for more. And then he basically tells us we need a flash loan, right? And of course we have the Uniswap pair here. So if we only have 1 ETH, 0.1 ETH, then obviously what we can do is, since we're going to get all the money, we're going to get our 15 ether back after getting all of these NFTs. Then we can just give it back to Uniswap, and we're going to get a reward from the free rider, the recovery. So then we'll be able to give Uniswap back a little bit more so that we can do a flash loan. Okay, so let's see. What do we need? We need if we want to do a flash loan, we need a function. So if we look up, let us look up the Uniswap V2 pair. Here we can see we've been a regular visitor of this. So what we need is essentially there's a callback that gets called, like the way the flash loans will work in a Uniswap V2 pair is that the pair will essentially loan you the tokens, and so it's a part of the swap. So when the swap is occurring, they don't validate that those tokens have been received until after the pair has given you those tokens. So what you can do is you can sort of get like a loan directly from the pair and then pay them back afterwards once you've executed, whatever arbitrage you're going to execute. So what we can do is, okay, in the keep being in the burn function, in the swap function, there's this. So there's this callback, and this callback is exactly what we're going to use to ultimately be able to get the 15 ether, and then we're going to use the 15 ether and we're going to buy one token at a time, and we're going to continue to do that in a loop. And then with every token that we get, we're going to send it to the recovery fund, and that's what we're going to do. That's what we'll do. So let's see. We need an attack contract. that implements this Uniswap v2 call. And then I'm thinking we'll have the attack contract as a receiver. So what we'll do is const attack contract equals, let me do this, ethers dot get contract factory. What we want to get is the attack contract, and this will be for the, what are we, the player dot deploy the what do we need? We don't know what we need yet, so we'll just do that, and then get a flash loan from Uniswap, get a flash loan from Uniswap v2 to address is the attack contract. Yeah, I mean, really, this is all we need to execute in here, and then the rest of the logic is going to be sort of waiting in the attack contract. So what we'll do is we'll create an attack contract, and let's see. What we need is we probably want to get some addresses in here through the constructor. And then we're going to need this function, Uniswap v3 call. And let's see. We have address, what is it? The sender amount 0 out, amount 1 out. So address, sender, uint. I don't even know if we're going to use these. Uint, I don't think we're going to use. We just need to get the money, and what is this? Bytes call data. Yeah, so we really just need to get the money and then be able to do stuff with the money, and then what we need to do is pay back. So okay, so let's see. So what is this pair? Basically just a stub token. I don't think it really matters. We're only going to be borrowing wrapped ETH. So here's what we'll do. So the pair is token wrapped ETH. We need ether. So what we're gonna do, withdraw 15 ether from wrapped ETH. And then what we want to do after we withdraw from wrapped ETH, then we want to buy tokens individually. Buy tokens individually from the marketplace. So what's going to happen, what I'm thinking is going to happen is we should get refunded. So I want to prove this out. And then we can make it work for all of them. So actually, let's do some like logging. So we'll get hard hat in here, and then so here's what I want to do. I want to buy a single token, see that we get refunded, and then yeah, so I'm just going to log stuff. So first of all, we're going to need a few things. We're going to need wrapped ETH. So here's what I'll do. We'll do address wrapped ETH equals wrapped ETH. We're going to need the marketplace to buy stuff from the marketplace. Need a little underscore, marketplace. And what else do we need? Buy a single token. That might be all we need right now. Okay, so to check this is all we need. So first of all, we're not in JS. So I want to just check the balance, make sure that the flash loan is working. So let's get val equals, I'm gonna make a what is it, balance of address this. And so here's what we'll do. We'll make a I wrapped ETH interface function balance of address returns uint external. Cool. and then console.log in this function and with this bow. And so let's see. So if I come here, so we have this. I need to deploy it with wrapped eth.address and the marketplace.address. And let's see if I do throw a dot only up here. Let's move these right there. Okay, great. I did not add a visibility modifier. Didn't see any logs because I didn't I didn't even do a flash loan. Okay. So what do we need to do? We need to do the pair directly. So we're going to do the uniswap pair dot swap. So we're going to do swap. Let's find this. So okay. Amount 0, amount 1. So the 2 is going to be our attack contract, and then data, this is going to get passed along to our attack contract, but we're not going to use it at all. So we're just passing in any arbitrary bytes just so that this can be called. Okay. So let's see which is token 0 and token 1. We want to borrow wrapped ether. Okay, token 0, wrapped ETH. So what do we want? We want ethers.utils.parse ether. We want 15 ETH, 0 of the other token. The 2 is the attack contract.address. And then we want some arbitrary, I think that should do it. Let's see what happens here. And there we go. Okay. So we have our flash loan working, and now let us buy a single token. So we need to withdraw. I need to withdraw now from wrapped ETH. So I need to add a function here. Function withdraw. I think it just takes an amount. So we'll do withdraw 15 ether. I think that'll work. And then we're gonna need another interface. We're gonna need marketplace. And this has this function that we want to interface with. In fact, we just copy this. Boom, boom, boom. Okay, cool. So now I want to cast this marketplace stop buy many. And what do we need here? We need so just any token ID, so I'll do 0. That should work. So then what I want to check is, let's see, I want to get the ETH bow, and how do I get the balance of an address again? Solidity get balance of contract. Address this dot balance, right? Yeah. Blanked for a second. Address this dot balance. Okay. So the ETH bow, then I want to say, so here's what we'll do. ETH bow before, ETH bow after. We'll do bow before, ETH bow before, and then we'll do bow after, ETH bow after. Okay. Let's see what happens. I'm expecting those to be the same actually, but of course we're actually just gonna not even be able to compile. So oh yes, okay, so this is going to be annoying. Let's just do this. Let's just do this. I don't want to deal with Solidity. Okay, so here's what we can do. Allow people, you pass in a list of token IDs, and then you just do uint I less than token IDs dot length, and then token IDs dot push should work. And then I need to come here and do 0. and do token IDs. Let's see. Of course not. That's right. This needs to be memory. Where is it? Memory. It should be called data. No, it needs to be memory. Classic. Okay. Hold on a second. So we're getting here, and then nothing. We're seeing nothing. Why is that? We'll do the classic debugging. So we're not able to withdraw from wrapped ether. Let us see. Did I get the withdraw uint? Should be fine. Wrapped eth. Did I pass the right address? Wrapped eth dot address. Let's see. Why is this silently failing here? Not even giving me a revert. Oh, you know what we need actually is a way to get ether. So we need a receive external payable. That's what we need. We need a way to be able to actually withdraw the ether. Okay, but we're still, I should be able to see now that, let's see. Okay, yeah, so now we're getting here. It's really annoying actually that we're not getting any kind of reverts right now. So let's see. By many token IDs is reverting. We need to actually give value. We need to give 15 ether. Oh man, let's see. Oh, let us await this. So we actually get some, well, yeah, thank you, Hard Hat. This is very helpful. Very helpful error here. Oh, exactly. ERC 721 transfer to non. So we're getting the token. I need to grab this one that has, no, not this. We need to just implement on ERC 721 received so that we can actually receive the token. That should fix all of our problems. Let me just remove this. Oh yeah, we need to return this dot, just some selector. We'll do that. Let's see. Override, of course, we're not overriding. Okay. Insufficient input amount. That is, okay, so that's good. That's what we expect actually. So look at this. Bow before, bow after is exactly the same. So what we're able to do here is actually just buy them one at a time and get the money back. So I guess if I want to, if we want to write some gross code and just do this, what I can do is, let's see, I can pop, push, yeah, we could do this really. So here's what I'll do. We'll do this, I less than, we want to go to 6, I plus plus, and let's see. Here's what we'll do. Boom. No more assigning of this. I'm just going to hard code it. Super gross. just to pull off the exploit. So we'll do token IDs dot push I token IDs dot pop. Right, this should do it. So we're pushing on initially, it's 0 empty array, and then we push on I, then we get that, and we get the ether back, pop, boom. Should still have 15 tokens, 15 ether. Ooh, not great. What does that mean? Unknown transaction override. Oh, you know what? We need to get rid of that. Great. So we have all the tokens now, presumably. We need to just send them to the recovery contract, and then after we send all 6 here, we're gonna get our prize, which is 45 ether. Cool. So let us, in the constructor here, take in another address, recovery, address, recovery, and so here's what we're gonna do. What we're going to do is, well, I need to get what that NFT is. So we have the marketplace. I think I remember the constructor. The constructor did token equals token, yeah. So we have a token. That's the NFT. So if I'm gonna come here, let us have an address token here, and actually let's make this, let's get that interface. Where is this? Boom. This is gonna be, let's see, this is right next to it actually. So if we do that, we have our damn valuable NFT. So what we're gonna do, I'm gonna have this be a damn valuable NFT, then token equals I marketplace dot token. Then we have that. I believe I'll need to do I damn valuable NFT. Dang, I missed that little parenthesis there. Okay. So on the marketplace, we need function token returns address. Address external. Okay. That should work. So we get our token, we get that token, we cast it to this. It's this. And now we can use this token. What we want to do is transfer. So we need to transfer in a loop, right? To the recovery. So what we want to do is we want to do for, actually when we, yeah, okay, so when we buy, it's not like we can send it there automatically. Okay, so for uint I less than 6, I plus plus. Actually, we don't even need to make it. Come on. Here's what we can do. Transfer the token immediately to the recovery fund. So what we'll do is we'll take our token and we will do what we need. Well, okay, so we want to safe transfer from, because we want to be making sure that we are calling this. It would actually be kind of disastrous if we didn't increment that one time. So what do we need? We need, I think this is, one of these is the operator. Token ID. What are those? I need to look up on ERC 720. Oh, they have a link for us. Let's see. Okay, operator from, right. Okay, so none of that really matters, right? I mean, they don't use either of those. Okay. Address 0, address, I mean, No, we do need to actually. Okay, so transfer from address this, and then we need to transfer to the recovery. We need to do, actually we don't have to cast that at all. Actually we need to assign that. We need to do recovery equals recovery. Okay, to the recovery, so it's safe transfer from this to the recovery, and we need I, and then let's check this out again. I, and then data, and they're actually using the data. Okay, so the recipient is ABI, so they're decoding the data that gets sent here. So I think, what do we want to do? We want to do ABI.encode. We need the player's address, so we need to go address player. So we're going to grab address player. We're going to go player equals underscore player, and we're going to encode that, and that should do it, to be honest. And then we need to pay back the pair, so we also need the pair or the message sender. That's what we can do. So we will do, oh, but we need to pay them back in wrapped ether. Okay, so we need to deposit again. I wrapped eth dot deposit 15 ether. That's not the way it works. You just send it value 15 ether, and now we have the wrapped ether. Now we need to do I wrapped eth dot transfer. We need to add transfer. It is 2 and then the amount, so we need to do to the message dot sender, which is the flash loan provider, and we need to give that 15 ether. And let's see, what am I missing here? Okay, I need to add this function transfer address uint external. Technically there's a return. We don't need to worry about that right now. So I think all should work. Well, of course it won't. I need to add deposits. Function deposit external payable. I made it payable. Don't worry, guys. That's right. Now I need to actually pass all of the stuff here. So what do we have? We have a ton of things here. We need the recovery. We need the player now. So the devs contract dot address, and then we need the player dot address. So let's see if this works. Nice big helpful revert string from Hardhat. Origin not beneficiary. Origin not beneficiary. Oh, that makes sense, because the transaction origin, right, that's what they're checking in this contract, right? The message sender has to be the NFT, and then the transaction origin has to be the beneficiary, which is the player, but we did not connect. Oh man, we did not connect to the player. So there we are, we've connected to the player. Now let's see, transaction may fail, Uniswap. So this is having to do with us returning, right? After, so we've gotten here for sure. About after, Uniswap isn't happy. Oh, we need to give, that's just because they want a little cut, right? They need a little bit more. We have to give them a little bit extra. Let's see. Hopefully that does it. It does not. Now we're getting a different error. Failed to execute. You know what? That's because we actually don't have, funny enough, I don't think we have, so we just have, this is all we have. We do have a little bit more. I mean, it's annoying. But we could, I guess we'll do this. We won't send it directly to the player. The money does need to make it to the player afterwards. So what we'll do is we'll do payable player transfer address this dot balance. What did we, so we got through it. We got through it. What is failing here? What is failing here? We're able to get all the NFTs. We got the rewards, right? So 135. So we're getting past all of this. Let's see, what are we? Clearly it's not 135. That is a lie. Let's see. Let's do the classic here one. Gotta see which validation here is failing. Here too. Okay, so it's this one. Exchange must have lost NFTs and ETH. Oh, so that's right. The marketplace initially does have some Ether. So actually, that's funny because that means that it actually means that we can totally do the original attack because, okay, so since there's already Ether in this contract, so we've actually just found two ways to exploit this CTF. So, okay, so there's the way that we have here where you buy one at a time and then you get basically refunded because you are now the owner. That is one critical exploit. And then another critical exploit is actually since the exchange actually, or the marketplace is pretty much set up for you to do this, since it already has Ether sitting there, what we can do is, yeah, we can just use the message value like duplication in a loop. And okay, so it looks like based on the validation, that is the exploit they're looking for. So I guess let's change this and do that exploit. So what will happen is, okay, so we'll just do this, and man, this is annoying. Here's what we'll do. For uint I less than 6, I plus plus, what we'll do is token IDs dot push I, and then we have our token IDs, we have all of them. We can do it all. We don't need to buy many here. Safe transfer from this can still happen. So what I'm thinking will happen here is we're actually going to get a ton of money. So we're going to get paid and this message.value is going to get duplicated. So now we're going to have more than 15 Ether after this is all said and done because we are also getting paid from this. So what that means is that we don't need to do this annoying stuff where we transfer. We can send it straight to the player. And there we go. So that's exactly what we've done. We duplicate the message.value and then there we go. Oh man, that took a minute. Okay, but we found two ways. So we got two ways to exploit the CTF, two solutions to the CTF. Technically, one of them doesn't pass the validation, but it is also a critical exploit. So we found two solutions to the CTF. I think that's pretty cool. I'm going to be honest, I thought this one was going to be a lot harder than it was. Yeah, basically the message.value really stood out to me. Really just because, honestly, I think because I've seen it before, right? Because I saw it in the project that Open Zeppelin had audited, and then they made changes and they introduced this bug, and then also had some experience looking for bugs like this when there was message.value used in a loop with a payable multi-call. So I guess if there's any takeaway from this, it's that as you see more things, as you work with more things and you dig into other projects you start to get more experience in certain areas, it will become very easy to, as you're scanning a code base, immediately flag stuff like this. And I mean, I didn't immediately see it. Of course, you know, we've been here for a while, but when you do see things like that, they do pop out to you, and you will immediately sort of say like, oh, well, I think that's going to be an issue. So I hope that this was, at the very least, fun to watch. Maybe you also learned something. Maybe you didn't know that using message.value in a loop was potentially critical like this. Maybe if you've done this challenge, go ahead and tell me how much faster you did it than I did. I took quite a while. This is probably going to be quite a long video, but I hope that you enjoyed it nonetheless, and I really hope that this will help you moving forward. So without further ado, of course, if you're looking to connect with other developers and join a community of over 500 auditors who are interested in growing and learning more and connecting and even teaming up and participating in team audits where you are rewarded for findings that you uncover as a team, then go ahead and go to lab.guardianaudits.com and apply to join our community of auditors there. And then also, of course, if you're not 100% confident in your Web3 security auditing abilities, then I collaborated with several other top-tier security researchers on exactly the product that you need, something that will take you from literally having just gotten a grasp on Solidity to being a complete, full-fledged smart contract security auditor in as little time as possible, as efficiently as possible. So if you are looking to spend money to accelerate your learning for any sort of reason, and you want to go down that path already, then of course you can take $50 off if you go and buy the Smart Contracts Hacking course in the link in the description down below. All right, that is all for this time. I cannot wait to see you in the next one.